To get a better sense of what a computer can do, let's briefly discuss its limitations. A computer consists of a finite number of instructions and memory cells. Modern computers can store billions of instructions and values in memory, but it is quite easy to build programs that use all available memory. Furthermore, we cannot store arbitrarily large values in these cells. For example, a memory cell is typically 1 byte in a real computer, which means that we can only store an integer between 0 and 255. We can chain cells together to store larger values. This will all become much clearer when we explore the components that make up the instruction and memory cells. In this course, we are going to write relatively small programs with small values in the cells, so we don't have to worry about hitting such limits. When we click Next, the simulator executes one instruction and then pauses until we click a button again. Since nothing changes in between clicks, the simulator operates in discrete time. When we click Run to completion, the simulator executes instructions one after another, possibly indefinitely. But the simulator still executes one instruction at a time and can only execute a finite number of instructions in a given time interval. Thus, the simulator is still operating in discrete time. A real computer behaves like the Run to completion button, executing many instructions one by one. A multi-core computer can execute more than one instruction at a time, but the number is still finite. Thus, real computers also operate in discrete time. You may have read or heard about 3 GHz CPU clock speeds and many gigabytes of memory. Hertz is a unit of frequency. 1 Hertz means 1 per second, or in this case, 1 instruction per second. Giga means billion, so a 3 GHz CPU can execute 3 billion instructions per second. Similarly, a computer that contains 1 gigabyte of memory can store 1 billion bytes of information.